Okay, so this video is going to be two more examples of hypothesis testing for the mean. So feel free to pause the video and try to work through some examples before watching the video. That's up to you. Okay, so here we have lobster trap placement and spacing. So for trapping lobsters, spacing measurements in meters for a sample of 7 teams of red spiny lobster fishermen are reproduced in the table. Let mu represent the average of the trap spacing measurements for the population of red spiny lobster fishermen fishing in California. I guess actually Mexico. So this is from another textbook, but we computed a mean and standard deviation. So we found x bar to be 89.9 and s to be 11.6. We want to determine if the true value of mu differs from 95 using alpha equals 0.05. Okay. So just as before, I'm just going to write down the information that was provided. So n here was a sample of 7 teams. Okay, n here is 7. X bar and s. So we were provided that x bar was 89.9 and s was 11.6. So x bar 89.9 and s 11.6. So mu naught, we want to determine if the true value of mu differs from 95 meters. Okay, so mu naught is 95, and alpha was given to us as 0.05. Okay, so let's start with our hypotheses. Start with the alternative. So what are we asked in this problem? We want to determine if the true value of mu differs from 95. So notice the word differ. Differ implies greater than or less than. So this will be mu not equal to 95, which means this is mu equal to 95. So let's just note that this is a two-sided test. Because again, we'd be interested in values greater than 95 and values less than 95. 2, test statistic. So t-stat, still the same formula. So x bar minus mu naught over s over root n. So we get 89.9 minus 95 divided by 11.6 over square root of 7. I get a negative 5.1 over 4.38, which is negative 1.16. Moving on to the rejection region. Again, this is the critical value approach. Okay, so this is two-sided, right? The rejection region follows from the alternative hypothesis. This is two-sided. So there's going to be two areas of our rejection region. So the rejection region. Well, let's first note that because this is two-sided, that means we need to divide alpha in half. So we're going to have alpha over 2 is equal to 0.025. So we're going to need t, n minus 1 here would be 7 minus 1, or 6. Alpha over 2, 0.025. So we will reject if t-stat is either less than negative t6.025, or if t-stat is bigger than t6.025. So let's plug in. So that would be t-stat less than. Oh, I forgot to look up this value. Okay, if we looked up t6.025, this would be 2.447. Okay, so returning to our rejection region, t-stat less than negative 2.447, or if t-stat bigger than 2.447. Okay, so let's make our conclusion. Okay, so our t-stat is negative 1.16. Is negative 1.16 less than negative 2.447? No. Is negative 1.16 greater than positive 2.447? No. So it's not in the rejection region. So we failed to reject the null hypothesis. So because our t-stat of negative 1.16 is between these two numbers, therefore, or thus, we fail to reject H naught. So we're not going to accept the null hypothesis. We're just going to fail to reject it. Okay, so now let's interpret this, which is there is not enough evidence to conclude that the mean trap placements are different from 95 at the alpha equals 0.05 level of significance. Okay, now let's do the p-value approach. Okay, so steps 1 and 2 are the same. I'm not going to copy and paste them down here this time. So let's just go to step 3, which is the p-value. So this is two-sided, which means our equation is 2 times the probability T6 bigger than T-stat. Right, because this is a two-sided hypothesis test, we have to multiply it by 2. So this will be 2 times the probability that T6 is bigger than 1.16, which will be 2 times 0.15, or 0.3. So if we draw a picture, so if I have 1.16 and negative 1.16, so our p-value will be these two areas. They're both 0.15. Okay, let's form our conclusion. So our p-value was equal to 0.3, which is now bigger than our alpha of 0.05. Therefore, we fail to reject H naught. Right? We reject when p-value is less than alpha, but here p-value is greater than alpha. And then our conclusion, our interpretation is the same. I'm not going to copy paste it down since I think we did that enough in the prior video. But I want to show one other thing. Let's just quickly do a 95% confidence interval for mu. So x bar plus or minus T6.025 s over square root n. So that's 89.9 plus or minus 2.447 times 11.6 over the square root of 7. Okay, simplifying this, 89.9 plus or minus 10.7. So we get 79.1 to 100.62. Okay, so we're 95% confident that the true mean is between 79.1 and 100.62. So let's just note something, which is that Mu naught of 95 in this problem is in the interval. So this agrees with our conclusion because 95 is a plausible value for mu. Thus, we fail to reject the null hypothesis. So, what we tested whether mu was different from 95. Well, we were 95% confident that the true average is between 79 and 100, and 95 is in that interval. So it makes sense that we failed to reject 95, that mu equal to 95. Now, let's say our alternative hypothesis had been mu equal to, I don't know, 75. Well, then if we could go back through this whole process, get a new test statistic, new p-value, but we would have rejected the null hypothesis because we can see that 75 is not a plausible value. It's outside our 95% confidence interval. So this leads us to a new rule, which is just that a two-sided hypothesis test is equivalent to a confidence interval assuming alpha is the same in both settings. So in this problem, what was our alpha? Alpha was 0.05. Okay, so what was our alpha for the confidence interval? Well, 1 minus 0.95 is equal to 0.05, which is our alpha. So the alpha was the same for this confidence interval. And so we could have established this interval. And now we know that we would fail to reject the null hypothesis if mu naught is anywhere from 79.1 to 100.62. And we would reject the null hypothesis if mu was either less than 79.1 or greater than 100.62. Okay, last example for hypothesis testing for the mean. So if you're sick of listening to me, I don't blame you. I recommend pausing the video, see if you can work through this by yourself, and then you can watch the solution. And I'm going to skip the p-value for this question, but I will use a confidence interval again, like we did in the last problem. So I'm just going to do critical value and the confidence interval. Okay, so we are studying anxiety for those who go to the dentist. So recall that scores range from 0, no anxiety. So I guess if you are strange and don't get anxiety going to the dentist, you would say 0. Or if you're like most of us, I would assume we're closer to 25. We get a lot of anxiety because, let's be honest, who enjoys going to the dentist? If I have any future dentists in this group, I apologize for what I just said. But I do not like going to the dentist. Okay, so we took a sample of 15 adults who completed the questionnaire, and we got an average X bar of 10.7 and a standard deviation of 3.6. We want to test whether the mean dental anxiety score for the population differs from 14, use alpha 0.05. Okay. I am going to go through this step by step. So we took a sample of 15 adults, so N 15. X bar and S, these were provided to us. X bar was 10.7, S is 3.6. So 10.7, 3.6. Mu naught. We want to know whether the actual mean differs from a score of 14. So this will be 14 and then alpha was provided to us as 0.05. Okay, let's do our hypotheses. What are we asked in this question? Can we determine whether the mean anxiety score for the population differs from mu equals 14? So notice the word differs. Again, it's not asking specifically greater than or less than. It's asking different from. So this is going to be a two-sided test. So mu not equal to 14, and this will be mu equals to 14. So this is a two-sided test. So a two-sided test, we always need to divide alpha by 2. So alpha over 2 will be 0.025. So then our critical value of t, so n minus 1, will be 14, comma, 0.025. And I get 2.145. Okay, now let's calculate our test statistic. So t stat x bar minus mu naught over s over root n. So x bar is 10.7 minus our hypothesized value of 14 over s here is 3.6 and the square root of n, or the square root of 15. So I get a negative 3.3 over 0.93, and so I get negative 3.55. Rejection region. So this is two-sided, so we're going to have two areas for the rejection region again. So rejection region will be either t-stat bigger than t14, comma, 0.025, or t-stat less than, actually, I'm switching these around. Let's be consistent. Less than negative or greater than positive. Greater than t14.025. So this is either t-stat less than negative 2.145 or t-stat bigger than positive 2.145. Okay, conclusion. All right, negative 3.55 is t-stat. Is negative 3.55 less than negative 2.145? Yes. So that means it is in our rejection region. So t-stat, which is equal to negative 3.55, is less than negative 2.145, which is our t14, comma, 0.025. So notice that negative 3.5 is not bigger than 2.145, but it doesn't matter. It's or, either or. But so because it was less than negative 2.145, we're going to reject the null hypothesis. So we reject H naught, accept H A. Okay, interpretation. So there is enough evidence to conclude that the mean dental anxiety score is different from 14 at the alpha equals 0.05 level of significance. Okay, but like I said, I'm going to skip the p-value here, but let's go ahead and do a 95% confidence interval. Which we know is x bar plus or minus t. In this case, 14, comma, 0.025 s over root n. So plugging in, that would be 10.7 plus or minus 2.147, right? That was our value. Yep, I have 2.145. So times 3.6 over square root of 15. So that'll be 10.7. I need to check my math because I had a different number there. So 1.99. And so our interval is from 8.71 to 12.69. So let's just note 14 is not in this interval because it is not a plausible value for mu. So we reject H naught. Right, if we're saying a range of plausible values for the mean is between 8.71 and 12.69, then it makes sense that we rejected the null hypothesis, which is that mu was equal to 14, because 14 is not in this interval. Okay, so that's it for examples on hypothesis testing for the mean. Next, we're going to introduce hypothesis testing for the proportion, which is very similar to what we've already done.